The atoms in your lungs right now were once inside a star that died before the sun existed, and astronomers just filmed the moment stars get shredded back into raw material, live, 650 light-years away. Every breath you take, every bone in your body, every drop of water on this planet, none of it existed until a star died first. Carbon, oxygen, nitrogen, the building blocks of you, were forged inside stars and only became available to form planets, oceans, and people because those stars eventually broke apart and scattered their guts across space. For decades, scientists understood the beginning of that story and the end of that story. What they never had was solid proof of the middle, the actual moment when stellar debris gets torn apart and mixed back into the galaxy. That gap just closed. In August 2026, a team of astronomers led by Yale researcher Peter Van Dokkum published a discovery in the journal Nature that gives us, for the first time, direct observational evidence of a dying star's remains being recycled in real time. And the wild part? They weren't even looking for it. They found it completely by accident. The target was the Helix Nebula, one of the most photographed objects in the night sky. It sits about 650 light-years from Earth in the constellation Aquarius, and thanks to the Hubble Space Telescope, it's often nicknamed the Eye of God because it genuinely looks like a glowing eyeball staring back at us from deep space. Astronomers have studied it for decades. It was supposed to be a simple calibration shot, a test image to check if a brand new telescope was working correctly. Instead, it exposed something nobody had ever seen before. That telescope is called MOTHRA, short for Modular Optical Telephoto Hyperspectral Robotic Array. It's currently under construction at the El Sos Observatory in Chile's Rio Hurtado Valley, and when finished, it will use 1,140 off-the-shelf telephoto camera lenses working together, paired with specialized filters designed to detect extremely faint glowing gas spread across huge patches of sky. Here's the part that should blow your mind. When this test image was taken in November 2025, fewer than 200 of those 1,140 lenses were even installed yet. MOTHRA wasn't finished. It wasn't even close to finished. And it still managed to reveal something the Hubble Space Telescope, one of the most powerful observatories ever built, had never picked up. So what did it actually find? 22 glowing arc-shaped structures, called bow shocks, stretched out far beyond the bright central ring of the Helix Nebula that most images show us. A bow shock is what happens when something moving fast slams into a slower medium, like the wake in front of a ship cutting through water. In this case, the ships are invisible clumps of leftover stellar material, and the water is the thin gas drifting between stars, known as the interstellar medium. As these debris clumps plow through that gas at incredible speed, somewhere between 35 and 45 kilometers per second, or roughly 80,000 to 100,000 miles per hour, they light up at the collision point, creating the glowing arcs MOTHRA captured. Here's why this matters so much. The bright ring at the center of the Helix Nebula, the part everyone recognizes, is only about 12,000 years old. To put that in perspective, that's younger than the oldest human agricultural settlements on Earth. That central glow comes from the final, dramatic gas ejection the dying star released as it collapsed down into a white dwarf. The small, hot, dense corpse of a star now sitting at the very center of the nebula. But the debris in those newly discovered bow shocks is older. It's leftover material from an earlier phase of the star's death, a slower wind the star puffed out before the final nebula-forming event. That material has been drifting outward for tens of thousands of years, and it's now in the last stretch of its existence. And that last stretch has a number attached to it now, for the first time ever. By comparing the bow shocks at different distances from the central star, astronomers noticed a pattern. The ones farther out looked smaller, fuzzier, and more broken apart than the ones closer in. That's not random. That's decay in progress. Using that pattern, The research team calculated that each clump of stellar debris survives roughly 10,000 years after colliding with interstellar gas before it fully erodes and dissolves, blending completely into the surrounding medium. Scientists had modeled this timescale theoretically for years. This is the first time anyone has actually measured it directly from real observational data. Why does any of this matter to someone who isn't an astrophysicist? Because this is quite literally the mechanism of your own existence, caught on camera. Sun-like stars burn hydrogen for billions of years, swell into red giants, shed their outer layers, and leave behind a white dwarf surrounded by glowing gas. That gas doesn't just disappear into nothing. It gets stripped apart, shredded, and folded back into the vast reservoir of raw material drifting between stars. That recycled material eventually collapses again under gravity to form brand new stars, and around those stars, new planets. Earth itself, and every element inside your body heavier than hydrogen and helium, exists because earlier generations of stars went through exactly the process Mothra just photographed. Roberto Abraham, a University of Toronto astronomy professor and co-author on the study, put it simply: most atoms in the universe aren't actually locked up inside stars or planets. They're floating out there in the thin, nearly invisible cosmic web between galaxies, and in the gas, drifting between stars within galaxies. That means catching this recycling process in action, watching stellar material actively transition from inside a dead star to floating raw material for the next generation, is a genuinely rare scientific event. Sun Kwok, an astronomer at the University of British Columbia who wasn't involved in the research, reviewed the images and said the level of detail captured in the nebula's outer halo was seriously impressive, especially for a telescope that wasn't even finished being built yet. There's also a deeply personal angle buried in this discovery. Our own sun is a fairly average sun-like star. In roughly 5 billion years, it will go through this exact same process, swelling, shedding its layers, forming its own planetary nebula, leaving behind its own white dwarf. Everything Mothra just documented happening to a star 650 light-years away is a preview of what will eventually happen to our own solar system. The Helix Nebula isn't just a pretty cosmic photograph, it's a mirror. What makes this discovery even more remarkable is how it happened. This wasn't the result of a multi-year, multi-billion-dollar dedicated mission built specifically to hunt for stellar debris. It was a routine calibration test on an unfinished, comparatively low-cost telescope built largely from off-the-shelf camera lenses, pointed at one of the most photographed objects in the sky purely because it's bright and well understood. And it still outperformed expectations, revealing structures that decades of Hubble imaging never picked up. That should tell you something about how much of the universe is still hiding in plain sight, waiting for the right instrument, or sometimes just the right accident, to reveal it. The Helix Nebula has been stared at by professional and amateur astronomers alike for generations. It's one of the most famous objects in the night sky, endlessly photographed, endlessly studied, and it still had a secret. If one of the most well-known nebulae in the universe was hiding a completely unseen recycling process this whole time, right in our cosmic backyard at just 650 light-years away, what else is sitting in plain sight across the rest of the galaxy that we simply haven't looked at closely enough yet? If a star dying 650 light-years away is quite literally rebuilding the raw material for future planets and future life, what do you think that means for how rare, or how common, a planet like Earth really is? Drop your theory in the comments. And if this kind of deep space discovery genuinely fascinates you, follow this page so you don't miss the next one.